All right, guys, good afternoon. So we're going to go ahead and finish out section 5.3. This video should go a lot shorter than the first one did because all we're really talking about is graphing. So I just want to remind you in example 9, the easiest way to go about graphing logarithms, first of all, is to change them to exponential form. So right now we have the equation y equals log base 5 of x. That's kind of hard to graph just looking at it. So what can I do? Well, if I want to change that to exponential form, I know that the number or letter by itself is always my exponent. So in this case, y is by itself. So 5 and x are going to go around the y, and y is going to be my exponent. So you have 5 to the y equals x. Well, that's a heck of a lot easier to plug points into. So y is going to be my input since it's my exponent. So we'll plug in some numbers, see what happens here. 2, -1, 0, 1, and 2. Okay, so we'll start with the easy part here. Let's say y is 0. Well, anything to the 0 power is always 1, so there's 1 point I can plot. What about if y is 1? Well, 5 to the first power is just itself, it's 5. And lastly, 5 squared there would give me 25. Okay, then we go when we do the negatives. What is 5 to the -1? Well, 5 to the +1 is just 5. So 5 to the -1 would be 1 over 5. Or you could write that as a decimal if you wanted to. What would 5 to the -2 be? Well, 5 to the +2 is 25. So 5 to the -2 is going to be 1 over 25. Okay, now I ran out of room there. There we go. And you could go over to Desmos or on my math lab and you could plot those points, and we'll take a second and just see what they look like. Right? 1/5, -1, 1, 0, 5, 1, and 25, 2. Again, I just want to reiterate to you, look what's happening here. Look at this graph. It's the inverse of an exponential. This thing would keep going forever. So an exponential would have gone up towards positive infinity super fast and would have been flat at the bottom. A logarithm does the opposite of that. At the bottom, it would keep shooting down really fast towards negative infinity. And you can see how as you go towards the top, and I can scroll over here, it gets really, really flat. Look how much space there would be, okay, between this point right here and the one all the way over here. Okay. Now, if you don't like doing this by hand, you are also welcome to do this right here. Desmos will graph logarithms for you. So you can type in log, and I'm going to hit shift underscore to get the base. So log base 5 of x, and it will graph that for me. Okay. You just may have a little bit of a harder time at times getting specific points. That's why I was showing you how to do it with the table, but you absolutely can get a picture of this in Desmos just by typing in log base 5 of x. All right, example 10. So let's look at what's different about example 10. First thing I notice is I see ln x. That means I'm dealing with a natural log here. And what does natural log mean? Well, natural log means that it's understood that my base right here is e. So if I'm going to write this in exponential form, what I have is e to the y equals x. Okay? And again, the reason I knew that is because it said natural log. So now, same procedure. If I want to get some points to plot, we'll do some positives and some negatives. These I don't know off the top of my head, so I use Desmos to help me. What is e to the -2? It's about 0.14. Okay. What is e to the -1? It's about 0.37. Okay, and I can keep going. Anything to the 0 power is always 1. Okay, e to the 1 would be 2.72. We'll stretch that out just a little. And lastly, e squared would be 7.39. Okay, and there's a set of points I could plot. Okay, but again, if I wanted to, if I don't like plotting points, and if you think it's easier this way, you can type in ln parentheses x, and it will graph that for you right over here. It's just, again, you may have a little bit harder time at times getting some specific points, but just keep in mind you have that option. Okay, lastly, example 11, again, is dealing with a topic we've seen a couple times this year. It's dealing with transformations, okay? So we're not going to worry right now about domains and asymptotes so much. I know it asked you for that. What I want you to be able to tell me is, how do I go from the graph of just regular natural log of x to one of these three equations? Well, if I look at example A here, what changed? Well, we started with just natural log of x. That's what it says right here in the prompt. But then we moved to natural log of x plus 3. Let me give myself a little more room up here to type. There we go. Well, what changed? We put a plus 3 inside parentheses with x. Well, if it's with x, that means it's either shifting our graph left or right. So how do I know which one it is? Well, it's a plus 3. I know that x values in equations swap signs. So even though a plus 3 would make me think that I'm going right 3, what actually is happening is that I'm going left 3. Okay? You look at part B, there are several different things going on. First thing I notice is this 3 out front. Well, that 3 is not like the 3 in part A. It is not in parentheses with x, which means it is no longer moving things up and down. It is no longer shifting things left and right. It's moving things up and down. So how do I know which one it is? Well, y values don't change signs. They do exactly what you would think that they would do. So if I have a positive 3 sitting out here, what I did was I went up 3. Okay? Next thing I want to deal with is you have a negative 1/2 that's being multiplied by the natural log of x. So we're going to break that down. The negative right here means that that graph has been flipped upside down. So the way we say that in mathy words is we say it's been reflected across the x-axis. Apparently, it's a good thing I'm not a spelling teacher today. Okay, so that deals with the negative. That 1/2 there, again, is not inside parentheses or anything like that with x. So it is dealing with our y values. Well, when we're referring to y values, we're talking about up and down. Another word for that is vertical. So this right here is going to be a vertical, and it's going to be a shrink because that 1/2 is cutting everything in half. It's making all your y values half as big. So there's how you would deal with part B. We are not going to worry about part C right now because you are never asked to deal with absolute value bars, okay? But that's what those are right there. But that should be plenty to finish you out in section 5.3. Happy mathing.